Welcome to the second training. In this session, I'm going to design, analyze, and documenting RCC column using Statica and concrete column application. I hope you will be with me to the end of this training, and please, as usual, feel free to ask any question under the YouTube command. Let's start. As you look, my Statica is open now. I'll just select the concrete column. If you see here is the code, Euro code, but the code version, just I will select Norwegian Annex, click OK. I go to the section database. From here, if you look, we have a standard according the Euro code, a standard cross section, and also we have non-standard. But in this case, I will use non-standard, and I will create some rectangle. If I go back to database, if you see, we have a variety of cross section here: T-shape, variable, cylinder, uh, F, L. It's same we have in a standard section, just you can put some value. But in my case right now, I would like to design just a rectangle. Uh, we have some here, some cross section is 600 by 600. I want to do something in this cross section. I will correct the name here 600. Just change. Okay. I select OK. Now the cross section is defined. What we can do now, the second part is we go to the load cases. If you look here, we have the load name. I will put the equation 6.10a. I would like to use one combination. I put some value here. I have a 50 kilonewton in MZ. I have a 60 kilonewton in MY minus 5,500 kilonewton and axial force in negative direction. This is this geometric imperfection. This according to Eurocode. I don't like to do anything with that. Also, I try to add here. Again, I go to use equation 16a. I put some value here 30 because it's serviceability limited state. Also, I put 40 here. It will be 4,800 SLS. Again, if you look, I would like to have this like long-term SLS. Now we have defined the load. One load for ULS and one load is for SLS for long term. The second thing, so we can go to the creeping. We have creeping for combination 1 and we have a for combination 2. As I showed you yesterday, we have some website here. You can see I just calculate I put my area saw column, perimeter, also the concrete capacity. I get here the value for my creeping. Also, I multiply by factor. In this case, I will put 2.2 in my ULS and I put 1.8 in SLS. Again, I go to the buckling. I would put some length for my column 4 meter. 4 meter. 4 meter. If you look in the uh, 4 meter for first combination, 4 meter here, 4 meter here. Uh, I go to the material. From material, we can choose XC2 or XC4 and or XC3. I think XC3. The life class is 50 years. I would like to change my concrete. The concrete capacity should be 40 according my creep calculation. Also, if you look here, you can see the stresses and strain diagram here for concrete. And you can create self also diagram if you want. You can create some material and put manually in the program. That's all. Next thing, I'm jumping to the river. I would like to put 25 dia, 25 dia, and the bottom on top. I change my strips to 12. If you look, that is the, if we have some concrete cover here, but what I can do, just I want to show, and I use the code control, code value. If I check the code value, it automatic get the correct concrete cover here. That is the fine. Let's jump to the next point. There is the use the minimum reinforcement, also the compression reinforcement, and the program also calculate automatic the minimum reinforcement here also. If you want to consider the correct, if you want to correct, also you can select this option and you put the value here for correct. In this case, I just off this option. But we have another option. This is for second order effect. We can use the two methods according to Eurocode. We can use the stiffness method and we can use the curvature method. These two methods defined in Eurocode, but what's the difference between these? The first is not calculate the second or the second order moment, not calculating the column. The the curvature method. This method is calculate the second order effect also in the column. It's increase the amount to rebar and the moment also. I will show you in the practice when during the design. But now everything is defined. I just go here. Now I want to link my load. Yes, all load is linked. Again, I will go to check my data. It's fine. I go to check material. Everything is fine. River is fine. Yeah, it's just fine. And everything is fine. I'll go to this my second calculation. I will check here. Yeah, everything is looking now fine. That means the first part is finished. We are ready to analyze our columns. Now I want to calculate my column. Now if you look, the result is available. Let's check. If you see here, we can see the moment from y direction. Also, you can see the amount. We have a 4 dia 25 plus for the minimum reinforcement. Also, we have initial imperfection moment 55 kilonewton. Also, we have 140 kilonewton. It's the total moment. Also, we have a moment in MY, the minimum moment we have M110, and also we have a moment capacity 930, and we have a utilization 0.1, 0.15. We can see the axial capacity here. It's axial load here. Also, we can see the utilization. It's 0.61, and also we can see the slenderness compression capacity and ratio here. Also the minimum reinforcement for strips, we can do 375. This is the minimum requirement for strips in our column. That's all. We have some here compression zone. If I select the compression zone, you can see there's a compression zone in my column. Also, you can, it was the MY. Also, you can see the M set also. If we have interaction diagram, you can see in MY, there is the diagram. Also, you can see the M set. Uh, I would like to show one thing. It's the, as a as earlier uh, saw. Just one moment. Again, I would like to show you another thing. So I just switch off this calculation. And now I would like to show you that this moment curvature method. If I select this, again, I would like to calculate my column. You can check the result. If you look the total moment is now increased. It was 140, now it's increased. And we can check the amount of the rebar here in our structure. The rebar is the same. The rebar is the same, but uh, anyway, the moment is increased. In some cases, we have a because we have a very high quality, high capacity in our columns. If in some cases, the rebars also change. If we design with that, we take care of the second order moment according to the curvature method. But the second thing I can do, just I would like to run control for surface visibility limit state. Again, I go to calculate. Now it's run. It's run. You can see here the result, and we can see here the compression stress. Sorry, the stress. You can see the diagram stress. Also, you can see the diagram strain here in our column, and we can see the compression zone, and we can see the interaction zone in the both direction. That's all. Again, I want to switch off this all of this result. Show the concrete capacity here also, but I can here we have some option. We can change the rebar here manually, and we can put manual reinforcement and concrete cover and layer, and we can put some standard rebar here, and we have some copy rebar. We can copy from one load to another case. If we have we copy from this case, for example, and put to from this current case equation 10 point and copy this is possible. Again, I would like to go to my design. The one thing I would like to do, just I want to decrease to my river. Just I would like to do 16 16 dia. Again, when I go to the load combination, just I would like to check another. It's no automatic cam and both combination. Now the river is changed. I would like to again calculate my column. Now the result is ready. I would like to see this result. You can see again, if you look, we have a 10 automatic. The program design, we need the 10, 16 in both direction our column. If you look, this is too much in 10 dia. But what I can do now, if I go again to change the design method, because you can see the effect of my design. When I go back to my design option, I would like to design according this equation. The methods, sorry, about this stiffness method. Just again, I would like to calculate. You can see if I again, it's not changed too much, but the moment is, you can see the moment is decrease. That's the two methods correct, but the only thing is you can just think about your structure, your load, and also about the situation. How do your structures act? You can self decide in which method you will use. In my case, I would like in always, I would like to design a little bit conservative, but I like to use the curvature method. Sorry, it was, again, I switch off this result. I go again to my design. I select the curvature method. I use the first combination. You can see now the result is available. Also, you can see the in the down also I have some. If I switch off this, all of this result, because you can from here, from option, you can decide how many report you will from the dynamic result. If you select choose alt, when you run analyze, you get a lot of information here. But you can see here also we have some results, the 3 page. You can see it here. But now I think that my design is now finished. Just I keep it like that. I just accept my design. The only thing I will show you in the last part, just you can go here and if you want to learn about theoretical background, you can just go to the help, select the content. If you select the content, you will get the theoretical background and little bit explanation about the manual, how to use the software. You can learn here more about that. You have a theoretical background. I will show you in the down. You have here. This is very nice software, very easy and very easy to learn. They are very explained very good in a good way to understand. If you see here is the nominal, the mid-base nominal stiffness, and we have a cylinder bending design. Also, we have a curvature method, and everything explanation is here. I think that is all for today. I hope I see you in the next episode. I just in addition, I inform you if you like to learn more about the Strusoft, please visit filmdesignstrusoft.com, and I am very sure you will access to several material, verification example, theoretical background, and a lot of tips and tricks from this website. And if you like, you can apply for, if you want to buy the licenses for this software, just apply, fill some first you can apply for some trial version. After 2 weeks, you can access, if you want to buy, you can access for 2 weeks trial, and after 2 weeks, and you can buy and use it in your company and enjoy with this software. This was all, but the last part is printing. Again, I go to my printing layout. I want to check here, addition. Now everything is fine. Just if I go here, I make print. I would like to copy in my desktop. Now the printing is also finished. You can see my printing. You can see the concrete material and the design value for ultimate limit state. And you can see here the concrete cover distance. You can see the column, the equation, also the calculation of cylinder bending capacity. You can see the total moment. You can see the utilization, and you can see the minimum strips. I think that is end of my end of the training. Just I would like to again approve my design. Yes, I will approve it. That's great. I can trust my job. Just I put approval here. That's all. Let's finish. But one thing more I will show you. If you want to put some things, here is a title block. You should put some description or something. Again, you go to the input, the title block. Just you can fill in here as your wish. Thank you again. Bye. See you in the next episode.